once maybe. But I'm going to show it here. Hydrostatic pressure is the pushing force. Remember this? It's the pushing force of water. Fluid. Fluid is anything that flows, including air. Air is a fluid because it flows. So if you push a fluid, that's called a hydrostatic force. The heart generates the force. We've seen this before, I think, on another slide. It sounds familiar to me this semester. So the pushing force is generated by the heart. It's a hydrostatic force. It says here, though, it's greater at the arteriolar end than at the venular end. So let's put that. HP is greater than something at that end. And it's less than something at this end. That's what it says in the notes, but it doesn't really explain it. I'm going to show it to you. There's another pressure. Again, there's supposed to be a second slide with this. There's a pulling force. I've given you this already, but what is it? Hydrostasis pushes water. What force pulls it? Starts with an O. It's your old friend. Osmosis. Osmosis is a pulling force. Pulls water, doesn't push it. And it pulls it based on the number of particles that are present in the system. We should all know osmosis. I know you don't, but we should all know it. I'm going to draw a couple pictures of it. You try to figure it out. But osmosis, the more particles, the more the pull. Right? So we have these two forces, and it's supposed to say, on this end, HP dominates OP. The hydrostatic force, pushing force, dominates the pulling force, the osmosis. And on the other end, it's opposite. OP, whoop, I should have did that backwards, hang on. I just did it right and then did it wrong. I'm going to go ahead and put the same order and switch my symbol instead of switching the characters. There we go. You do it either way, but it looks better that way probably. HP is greater than OP on one side, artery side. HP is less than OP on the vein side. So what does that mean? Well, very simply, just think, what's HP mean? What is hydrostatic pressure? It's a push, and then the OP is the pull, right? So we got particles in the blood. We call them blood cells, and plasma proteins, and all other kinds. We have particles in the blood that can suck water in. But it's saying here at this end, the push is greater than the pull. Therefore, there's a net flow out. This is how we get leakage. This is how we get that exchange mechanism. We want low pressure, and we want it to be bigger than the pulling force or the sucking force back in. Water is being sucked back in, we just don't see it because the push is winning. So we want some pressure. If we had zero pressure, osmosis would win. It would just suck up water into our system and we would have no exchange. We have to have some pressure. So that's showing this a little differently. HP dominates OP at the artery side, the arterial side. This stuff that's leaking out, yes, it's got goodies in there we're exchanging with tissues, but some of it's just crap. What's the stuff that's leaking from the tissue column? Exudate, right? It's exuding from the tissue. Most of it's just clear, watery exudate. There's nothing really wrong with a puddle of water except put one in your backyard for a few months. Tell me what starts to grow in there. You don't want puddles of water, even if it's nice water. Some of that exudate becomes bloody, shouldn't have that. Some of the exudate becomes fibrous, shouldn't have that. But you'll learn about that in other classes. We just need to know that this side, push wins. This pushes exudate out of the capillaries. Yeah, the good stuff comes with it. We can do exchange with it back and forth, that's fine, but too much is too much. Now on this other side, who's winning now? Well, think about this real quick. As I suck water out of here, what's left behind? The particles are left behind, right? So when I go across here, I'm not actually adding more particles. It just looks like there's more particles. I'm not going to do the whole thing. It looks like there's more particles because I've sucked all the water out. And so that's what I'm trying to show here, but I don't want to do dots on the whole picture. Remember, we haven't added particles. It's the same number of particles, the same number of white cells, same number of red cells, same number of plasma proteins, same number of hormones that there were before. We've just pulled out water now. We dried it out. You got a cup of salt water, you dry out the water, what's left? The salt. The chunks are left, right? And we know that if we have a lot of chunks, a lot of particles, that will start to suck in water through osmosis. So on this side, water gets sucked back in. HP is less than. OP dominates. The sucking force wins. And we suck up, vacuum up some of that water again. Some of it. So some of the exudate that leaked out, we can clean up on the other side. But not all of it is cleaned up. So what we need is a second system, the lymphatic system, to clean up exudate. If you're ever wondering what lymphatic system is about, that's what it's about, clean up exudate. And we're about to do that here. We'll see it in the next chapter as well, but I'll show you the whole lymphatic system like one drawing here. Super easy. First, just draw some fingers that are green, is usually how they're drawn, and intertwine them in these capillary beds, like they're interwoven in here somehow. We got these green tubes, looks like little cactus accesses. Just blend them in here like this. Put one up here, happy little cactus. Oh, that's great. Let me see, Asher. Okay. Let's put some green fingers kind of intertwined with the capillary. It's like kind of coral snaking through. These are lymphatics. We call them lymphatic capillaries. They're collecting exudate. Again, we'll see them work. They're very, very much like veins. Very much like veins. We'll clear that up later. That's just what's happening is they're cleaning up excess exudate. I know I can clean some up on the other side, but there will remain some fluid out there, and you don't want it sitting there persisting. So the lymphatic system is going to clean this up for you. All right, so we have exudate leaking out. We know why, because there's more push pressure than pull pressure on that side. On the other side, we can clean up because there's more pull pressure than push pressure. But what happens to it once the exudate is inside of the lymphatics now? Well, first of all, at some point, when the exudate's inside of here, it turns into lymph. It's not called exudate anymore. So any kind of fluid that's in the tubes now is referred to lymph. So lymph is just all the dirty crap that leaked out of your blood. All the stuff that leaked out of a capillary and got vacuumed up by a lymphatic tube, that's called lymph now. It's the same stuff that it was. It's just got a different name now. You can call these things out here like lymphatic vessels, but we don't have things like arteries, veins. They're just called vessels. There's capillaries, there's bigger ones, there's bigger ones. And later we'll learn two major ducts, and that's it. It's a very simple system. So I've got lymph in here. It's cleaned up exudate. There's all kinds of crud in there, bacteria, viruses, dead cells, all bunch of crud is leaked out of the blood there. We need to deal with that. So what we can do is, it's called running the gauntlet. So this isn't really part of the drawing, but I'll draw it anyway. Back in the days, if you were like a bread thief, you stole bread or whatever, you beat the cat or whatever, the town would punish you by standing in two lines like they do at the football game today. Cheerleaders all stand in lines and the football players run in between them. Oh, we're going to kick their ass and all that stuff. So it's the opposite way here now. There's the bread thief. He's going to, for his punishment, he's going to call what's run the gauntlet. And as he runs through here, everybody in town has sticks and bats. And he runs through here, they just beat the crap out of him until he gets to the other side. And they're like, don't do that again. That's a really good form of punishment. I think they should bring that back. Running the gauntlet. So there are other horrible ways to deal with you if you're like a child molester or something. But if you're just a little common thief or something, they would just have you run the gauntlet. That's what we're going to do now with these cruddies that are inside the lymph. We need to have them go from room to room to room, and every room they go into, they get their ass kicked a little more. It's So what are these little rooms they're going to go into? Lymph nodes. If you could get a camera in a lymph node, man, there's some action going on in there. Murder and murder. Lymphocytes, right? T cells, B cells, those really scary NK cells. That's who's doing their business down here. That's the immunology chapter coming. But as you go through here, that's running the gauntlet. You go from one node. If you happen to make it out of one, there's another one. And if you happen to make it out of that one, there's another one. And on until you're just beat to hell. At some point, when you're all clean and pretty, let's get you back to the heart somehow. And now we have the idea of what the lymphatic system is about. That almost covered the entire lymphatic chapter, believe it or not. We will go through it officially next time. But that's 80% of the questions on our hysterectomy. We'll get into the details of the nodes and the lymph node gone wild, known as the spleen. But this is the idea of the lymphatic system. Okay? I think we got it now. I think I'm done with this one. I don't have any picture takers or recorders, guys. It's weird. You want to record? Okay. This one's going. Pressure, handsome lift, all at the same time. Beautiful. Okay, that covers the missing slide. The missing slide said osmotic pressure and then just said kind of what I said. How many questions am I going to ask you about this? Not many. Not many. I can't. I mean, there's not a whole lot I can ask, but I'm seeing the answers up there, so if you study what I'm giving you, that's what you need. Okay, shock. What's shock, you tell me? I just told you, tell me. What's that? Extreme drop of blood pressure. You could get shocked by being shocked, right? By electric shock, but it's not the same word. It's not the same word as she's in shock. Learning bad names, that's not the same thing either. So, yeah, it's an overused word in English for lots and lots of different things. But when you talk circulatory shock, I mean super drop of blood pressure. What's wrong with that? Well, blood's not moving. Remember, flow is linked to pressure. If you have no flow, you have no pressure, and there's nothing moving. Vessels are not filled, they start to collapse, you're not feeding tissue, hypoxia, and bad problems happen, right? So I would know these three. The roots tell you, but people forget them on like fill in the blank things. Hypovolemic means literally what? Low volume. Yeah. Your arm is ripped off, and you're gushing blood onto the floor from your armhole. Yeah, you got EPO, you can make more red cells, but you can't make them that fast. So that's a problem. You're gonna drop blood everywhere, and pretty soon you're gonna run out, right? You've only got 5 liters. So this is the most common way to go into some kind of bad shock event. It's just to bleed out, either all over the floor or internally. If your aorta ruptures inside and you just dump blood all inside your body, I mean, it's the same problem. It's not moving through your veins and arteries and so forth. So hypovolemic, most common. What's the most common form of circulation? Hypovolemic. Vascular has to do with the vessels, right? Has to do with the vessels. So what happens here is the tubes, your actual vessels become extremely dilated. Notice the word here, it's not dilation, it's just dilation. Everyone says dilation, I don't know why. It's like they say athlete, they just do that kind of stuff. So vasodilation, there's no word dilation, it doesn't exist, just dilation. Vasod is what I call it, so I don't have to say it out loud. Vasodilate, extreme peripheral dilation. Extreme peripheral dilation, meaning decreased peripheral resistance. The tubes are too big, nothing's flowing through the pipe. That's it, the tubes get gigantic. This can happen in a number of different ways. Don't try to figure out all the ways. Taking the wrong drug, if it can do it. There's any number of things that can do this. Cardiogenic starts in the heart. Cardiogenic. These words tell you, hypovolemic, low volume, vascular is a vessel, cardiogenic, heart did this. The heart stops beating. Well, that would be bad. Or you're fluttering, you're in fib, right? If you're fibrillating, or your heart's not moving at all, well, you can't pump blood, so that would be a cardiogenic shock. The heart stops, or flutters. I will definitely ask you those, for sure. They're easy, but remember the names, don't confuse them. shocks. Drop blood pressure 3 different ways. Lose blood, superdilation, or the heart not pumping. Okay, blah, blah, blah. We did this a long time ago. Pulmonary, systemic. All we need to do is worry about, these right here. Okay, that's what we're going to draw here. We're going to attempt to draw this one. So I'll play that. I wish I could do this on the board, but the boards are this way and not that way. I really need a long piece of paper. So if you can take your paper and turn it lengthwise, that's the way I would draw these, because we got to kind of draw a person, and it's hard to draw them sideways. So that's what we're going to do, is draw the major vessels of the body. We're not going to learn every single vessel in the body, because that's stupid. Okay? I'll learn the big ones. I'll show you how to deal with this. I'll explain how to deal with this. The first thing to know is there will never be a picture like this on the test. There will not be pictures of arteries and veins, and you'll have to label them, except for the biggest ones. I mean like the smokestack ones and so. I'll show you what you need to know as we go through here, but you don't need to be able to find every single one of these. So my first thing, and I'll probably give you a bunch of hints in a fractured order, because I don't ever remember till I see it and make a point here. So if I'm talking arteries, I'm going to use words like feed, tissue, supply, right? And synonymous words. So I'm getting you to tell me the name of a vessel. I'm using words like feed and supply. That would probably be, I'm an artery doing that. What words might I use for veins? It's a little harder. If arteries supply or feed tissue, what do veins do? Well, it rhymes with it. Veins drain, right? Tissue. Or some synonymous term. This will help you. Remember, tests are just word plays. You can figure out the words, the test is easy. People get hung up on the words and they try to fight themselves over the words. But keep it simple. Veins drain. You know what drain means? Take something from somewhere and move it out away from it. So we know arteries go away from the heart. Veins take stuff back toward it. When you're talking about the organs, arteries are going to feed those organs, and veins are going to drain those organs. Okay, I'm just giving you some hints here how you're going to. Remember, not going to see a picture of this. A picture of this. It's going to be words, but I'll tell you how. Okay, we're going to draw most of this, but look at this. If I had a matching section, and I ask you to name the artery that feeds the pericardium, what's it called? The pericardial artery. How much you want to bet that you could match that all on your own without me saying anything? I bet you could do that, right? I bet you could know that the bronchial artery feeds the lungs, right? Because I bet you know that the esophageal artery feeds the esophagus, right? I bet you can figure those out. There are some here, maybe like phrenic, you can't figure out. But the ones you can figure out, I'm not going to talk about those. Those are too easy, especially on like a matching type of a thing. I want to really do a drawing up here. It's like the first one we're going to do, and I hate the way that looks. It just looks ugly. And then we're going to do a drawing down here. The branches of the under the diaphragm. We're going to kind of skip that middle part mostly. We'll talk about them a little bit, but God, that picture sucks. And then this one, we're going to do the upper part here, which should be an exact mirror image as the side, but they just cheated and said same as that side. It's so terrible. They like cheated you half of the image out. Yeah, I know it's the same thing, but man, if they showed that, it would show you that that's not symmetrical, and that is symmetrical, but you can't tell because it doesn't look like it. So they're terrible pictures. We're going to do 3 drawings of this, 2 of the arteries and 1 of the veins. Just, I'll tell you how I'm going to deal with it, but feed, supply, drain, things like this, okay? Most of this is going to be oxygen rich. In fact, all of this is going to be oxygen rich. And all this is going to be oxygen poor. We're just going to play the game here. We're not going to talk about the details. Okay, remember these shunts? I do. We already did it. They're in another chapter. It repeats itself. So I don't care about the shunts. Just remember their thing. I'm more concerned about, let's draw these arteries here. Let's see what we can do here. So I usually mess this up. I even brought my cheat sheets because I usually mess this up. What it means is you might want to wait a few seconds until I say, okay, that part looks good, instead of drawing and then me erasing and you going, like a little 5-year-old. Remember, I can barely fit this on here, so I'm gonna start low. Let's see where I can start. I can go way down here. Let's do this first. I can do this part easy. That part won't change much. I need game over. Victory. We can go that far. Keep doing that to me. Okay, I think we can go there. I'll wait until I do the next part. That's these little gaps here, intentional. Okay, let's try this. I already see an issue coming. Why didn't you do that? You can do it. Okay, here's where it gets weird. Mhm. Got it, barely. Okay, try it. Try it. If you make it small, you probably already lost. Right? Mine always, the head, I have to cram his head down because it makes it too long. So you should be picturing is 2 arms coming out, a neck and a head. You can see that, and you can see the major arteries at the top of the heart, the arms, and the neck and the head. That's what we're looking at here. As weird as it sounds, on the test, I actually show pictures of real angiograms of people's actual vessels. And if people can draw this themselves, they can tell me the names of those vessels on a real angiogram. So as silly, as ugly as that looks, it works. And I will have that as bonus on this next test. I will have some angiogram pictures. And if you can tell me the names of the vessels, you'll get bonus points. If you can draw this on your test, which you'll have time to do, and label it, you will miss nothing about the names of these vessels. And that is truth. So practice it. Stay after class. Try to scribble it on the board. If you can do it 3 times in a row, you're done. Label this arteries. So we know we're talking arteries here. You may even help yourself just by showing arrow. Leaving the heart, we're heading up. Every tube here is going away from the heart. I would probably do this the same way we did some other things, just label this 1, 2, 3, 4, 5, 6, 7, make yourself a key somewhere so you can't cheat and study at the same time. We'll try it that way. Now the weird guys in the back are the weird ones. Let's make them fit somehow. I put them too narrow so I couldn't get them in there very well. Okay, let's play. Now the first thing to notice is this is almost symmetrical. What's stopping it from being symmetrical?
The two on the sides.
This stupid tube right here. If I would get rid of this and just take this tube and this tube, and we'd have 1, 2, 3, 4. And it'd be nice and symmetric, but man, that's gonna drive you nuts. Okay? If it weren't for that, we'd have symmetry. The veins are going to be symmetrical. Left side is right side. This is different. There's that little bitty dude right there that makes everyone lose their marbles. This little dude here has a different name, this little tiny guy, than anything else. So let's work our way through. Well, I'm coming out of the heart. What are these very, very first two guys at the bottom? Those are the coronary arteries. We've seen that before. I'm not even going to label that because that's not major. That is the first branch of the aorta. If I ask you, remember, that is the first branch, but it's not a major branch. The major branches are those 1, 2, 3 smokestacks at the top. So we know what those little guys are. We know that's the aorta. We can start saying, like, here's 1, here's 2, here's 3. We can do something like ascending aorta. Is that on the screen? 2, aortic arch. 3, descending aorta. Yeah, okay, we can do that. That's not really useful to us much, but that's fine. We can make a little arch, ascending aorta. Aortic arch where the 3 smokestacks come out at the top. And then the descending aorta. If you want to remind yourself, you can put a little arrow showing, hey, the blood's going down this way. It's also coming out all the tubes, but if you put the arrows everywhere, it turns into a mess. Of course, it's going to shoot up the tubes here. These are all arteries. Okay, there's the aorta, no problem. So the trick here, and I'll just show you the trick, then I'll erase it, is this. You do the ABCs thing. You do ABCs. I used to do it. I don't do it anymore. But that makes I know it now. But it's the time I used to, and I'd get messed up. The ABCs. Let me tell you what it means. A's for aorta. Right? We got the A down, no problem. Aorta. The B, I'll put it up here. And it's, again, it's this little tiny tube that goes from here to here. Once you get to the split, they're 2 different guys. That's usually the rule. When you come to a split, everyone's going to change their name a little bit. So I can put a 4 here where I have a B. Remember where this is going. Blood's going where? Well, if it goes this way, where does it go? Right arm. Well, if it goes up here, it goes brain. Okay. So arm is brachio. Brain is cephalic. Brachiocephalic artery. We call it brachiocephalic trunk. The VC trunk. Keep it real short, but brachiocephalic artery. That's the only one. There's no left or right. There's no symmetry here because of that dude messes up our symmetry. So we don't have a left or right brachiocephalic. It's just the single brachiocephalic artery. When we have the veins coming back, we'll have the left and the right brachiocephalic vein. So here there's only one artery that named BC brachiocephalic. Okay, the C there, the next one, let's just do this, 3 major smokestacks, the 5 here. C, it's a carotid. And it's on the, which side, left or right? Left. So LCC is what I usually write, just to keep it real quick, but don't do that on test. Left, common, carotid, artery, all that. LCC is just how to write fast. Alright, I can kind of cheat here, I can put BC, LCC, just fill in the gaps. Don't do that if you want to study, you can just leave the numbers, you do it however you want. Okay, there's my LCC, left common carotid artery. The word common suggests it's going to break in a little bit, and it will, look up, it will break. I bet there's going to be, since there's a left common carotid, there's probably going to be a what? Alright, okay, that's where we get to the symmetry, but that BC trunk messes us up. 6 over here. The S sub, yeah, it's going to go under the arm. I should say it's going to go to the arm, under the clavicle. So under clavicle, and it's all this out here, it keeps on going all the way down. Left, you got to give me lefts, you got to give me arteries, or it's half points. Subclavian is the root for clavicle. Left subclavian, left sub C, sometimes you hear me call it. I'll just put that there. Left sub C. Subclavian. So how could I ask this on the test? Many ways, but I could ask, what's the second major branch of the aortic arch? Left common carotid artery. What's the third major branch of the aortic arch? Left subclavian artery. I could ask those very easily. Okay, now we need to deal with symmetry that's not symmetry. So again, if you just rip this tube BT trunk out of the way, and you have this guy come straight down, and then this guy comes straight down, it looks exactly like that. And it's got the same names, but those are the right sides. So if I went all the way up here, if this is LCC, what must be this one here going straight up? That's RCC, right? So I'll put a 7 here. Remember, this is still 5. It doesn't change his name. This guy changed his name because we had a branch, a stupid BC trunk. Who did that? Get that guy out of here. 7. Right. Common carotid artery. Now this is RCC. That's now called a right common carotid artery. Maybe fit him in here. RCC. This guy's still LCC. He never changed. That trunk got in the way. Okay, let's go to the other side then. Who's this one coming out here? Well, he must be the right sub C. Yeah. So 8. Right sub C. Right subclavian. Artery. Give me the rights. Give me the artery or vein. Don't just put sub C. So now we see the symmetry. Again, if that BC trunk were out of the way, we'd have perfect symmetry. There's how to deal with the common carotids going up the neck, and the subclavians going under the clavicle. And then now follow the common carotids up, and we're going to split like most commons do. So we can, I don't know, let's do something like this. 9, 10, 11, 12. I don't know, it sounds good. And usually when you have this, internal and external are a really favorite way to go once you have a common branch. We'll see some others too, maybe a left and a right. But let's try this. So 9, what side is it? Left. And it's heading away outside from the brain, not into the brain, but out from the brain. So that's the, I'm going to write it in an external common carotid artery. Just going to kind of abbreviate all over the place. It's not the left common carotid, it's the left external common carotid, or I sometimes call it LEC. Mine is LEC. 5 is LCC. Mine is left external common carotid. Guess what 10 is? So it's L-I-C, lick. Lick and like. Lick, left internal common carotid artery. It's got the same as the left. It's lick now, internal is the only difference. Very common for commons, you see that happening. I bet you know 11 and 12. Who's 11 and 12? 11 is my cousin Rick. And out on the outside is his brother Rick and Rek, and Lick and Lick. So same thing, and I'm just gonna leave them like that, because it's the same convention. Right internal common carotid, right external common carotid arteries. So there's those branches there, the Rick and Rek branches. Remember, right, left, RL, that's easy. Internal, external. Okay, I could ask you on the test. The left common carotid artery branches into which two arteries? You tell me the left internal common carotid, the left external common carotid. That's it. Or I could say the left internal common carotid, the left external common carotid began as one artery called the what? You say left common carotid. Again, if you have the picture drawn, you could just read along with the question, map it out. You can easily find the answer. Okay, some others here. A few more. These weirdos that go back behind here. These weirdos that twist in and go right up the back of your neck. They go right through the cervical foramina, the little holes, then what I call them ear piercings in the cervical vertebrae. That helps you remember their name. So I'm just going to put 13, are we on that? I don't know, 14. 13, 14, left and right vertebral, as they run through the vertebrae, arteries, left and right vertebral arteries. You can give yourself an arrow here if you need to remind yourself which way everybody's going. We're all going away, going toward our tissue. But up or out. Okay, so there's the vertebral arteries, 13 and 14, running up the vertebrae. The weird thing about the vertebral arteries, the most asked question on test about the vertebral arteries is this one of the weird arteries that actually combines together. Remember, most arteries split and split and split and split and split. There are very few I can even think of that combine with each other. Usually we hear the word confluence with veins. Veins flow together to form a bigger vein. 15 is actually a giant artery made by two little arteries coming together. It's weird though, so I'll fit it over here. It's at the base of the brain. That circle is right under your brain. So it's at the base of your brain. It's called basilar. Basilar. It's at the base. Basilar artery. I could ask on the test, which artery is formed from the merging of the two vertebral arteries? Basilar. Again, if you have your picture drawn, you can refer to it immediately, and that's it. Okay, then you have all these guys coming in and more, and I'm not going to draw this